All right, so today we want to talk about network configuration. We're in chapter 12. And let's start by talking about networks in general. How would you define a network? You know, in your own words, what would you say is a network? We're going to talk about. Excellent. Two or more computers working together. I like that. And today with virtualization, it could actually be even one computer, and then you can run multiple virtual machines and actually test a network, which is really, useful. You don't have to worry about wires and things like that. Yeah, so two or more computers. Sometimes networks are defined actually with a purpose, that the computers are connected in order to share resources. The definition that I like is that a network is really a broadcast domain, because it allows you to, within a network, you can do certain things that once you connect through a router somewhere else, you are unable to do. Okay, so networks, yes, they're connected computers, and usually we talk about sharing certain services or resources like internet connectivity or a printer. Okay, so networks, once they're connected at the physical layer, once they are connected at the data link layer, they're going to use certain protocols. Now, what protocols do you know that can be used on a network? Okay, so those are two protocols already, right? So IP is a very, very popular and successful protocol. IP standing for Internet Protocol. Sometimes we are redundant in calling the IP protocol, right? Because it already has the name protocol in it. But IP by itself is not resilient. So what it means is that IP is designed in such a way that you send out a packet and you're very optimistic in the fact that it gets places, all right, by itself, which is why it often is connected to TCP. And TCP provides additional functionality in actually being able to know that the packet is going to be resent or it's going to be delivered with a certain level of confidence. All right, any other protocols? UDP. Okay, so you can have IP over UDP, which has a different nature, which basically is just best effort. Any other ones? Any other ones in addition to those? Some of them are listed on page 526. IPX, yeah. So IPX is connected with Novell. It's a protocol that they developed, and Novell is a great company. You know, they did some really great coding over the years. Today, you know, their success is I'd say a little bit limited. And IPX sort of went into history. But with IPX, you could have Linux, you could have Windows, and you had to configure a new protocol in addition to IP, and it was called IPX, and it will allow you to communicate with other workstations via that protocol. Well, a lot of times it meant that you wanted to connect to a Novell server. So you could map a drive, and there was for a while, there still is, I think, a Novell client for Linux. So you could install Novell client, you would get the Novell prompt, and you could use actually IPX with that. All right, very good. So those are protocols that allow us to transport packets, allow us to connect to remote systems. Another family of protocols called the application protocols are a little bit higher on the OSI model, and these application protocols actually enable the various software pieces on the server and on the client to communicate. For example, we have FTP, File Transfer Protocol. So if I have a file, I'd like to put it on the server, I go ahead and use FTP. It's an application layer protocol. Any other application layer protocols you can think of, please?
My favorite, SSH.
Okay, SSH, great. So SSH, the secure shell, allows us to connect remotely to either Windows or Linux, and have the terminal, they call it command prompt, over secure connection. Great. What's its unfortunate brother? What's the other protocol? Telnet, that's right. I wasn't going to use other words, but let's just say unfortunate brother. So Telnet is out there too, doing the same thing, functionally wise. But what Telnet, of course, lacks with is security. Because with Telnet, you actually are connecting without encryption. So without actually getting on the Linux system, on the Windows system, there is a utility called PuTTY. And if you Google putty.exe, the first result will take you to a download page. This kind of software installation process is a little bit suicidal, right? You Google an exe program and then you download it. But with PuTTY, it actually works. So when you go to look for putty.exe, you just grab this this website and download putty.exe. What it allows you to do is it allows you to reach Unix-type systems from your Windows host. So now you see I can choose Telnet, I can choose SSH, I can choose remote login and others, and actually access a remote system. So I can go ahead and log in to, let's say, the Raider system, and it asks for my credentials, and there we are. So this would be example of SSH. Now let me see if Telnet might work. I'm not sure if we have that enabled. Telnet to Raider, and so when I misspelled it, Telnet. Yeah, that doesn't work either. So let's see if I was to restart and select Raider. Okay, so Telnet is also installed on Raider, and so you can see that it's the same functionality. I still get a black screen and I can issue commands if I know them. The nice thing about SSH is that this service does not just provide the shell access, it also, SSHD, and that's the daemon we'll play with next week, it actually also provides things like SCP. So I can say SCP, certain file, and go ahead and put it onto a different host with an IP address of something funny like this. And so what this command does is it says copy in a secure way over the network this file, then log in automatically to the SSHD daemon as this user on this remote host. Try to copy this file to the current directory, the home directory for the host. And if I press enter, it would ask me for my username, it will ask me for my password, and the file gets copied. The other great thing that you can do is you can, with SSH, you can share your public key to a remote system, and then as you do SCP or as you ask for SSH prompt, you do not even have to log in. You can establish trust between multiple hosts. So imagine that you're doing a backup of your database, and then you automatically, with a bash script, you're moving it to a remote system. See, it's a nice way to do a very simple backup over a secure connection. All right, so that's a good example of SSH. Any other application level protocols that that you're familiar with? Okay, great. HTTP, and HTTP is a protocol that we will look at next week when we talk about web services, hypertext transfer protocol, which allows, of course, the World Wide Web to exist. Here's an example. If I was to perhaps say wget --spider-s on HTTP www.grc.edu, it's going to show me the whoops. Oh, spider. So it shows me the header for the HTTP protocol, and the header says, okay, we are going to use HTTP version 1.1. Here's the current date. The server that I'm connected to is an Apache server. It's running on Unix, running an older version of PHP. The page that's coming back is going to be of type text/HTML, It could be PDF, it could be an image. That's how the browser knows how to render it because of this header. And it gives me other information about keep alive. If there were any cookies, the header would actually include cookies as well. So, so that's the example of HTTP. Any other protocols? Okay, DNS. So DNS being domain name service or domain name services or domain name system. There it is. I've seen it both ways. So we can see an example with wget how DNS works. One of the steps that this little utility wget will go through is it's going to resolve the name I typed in to an IP address. You see, human beings are not good at remembering numbers. You know, you remember your weight, your height, but out of all the contacts in your phone, right, how many phone numbers you actually remember? If you have friends, then you probably will say some. So we don't remember numbers well, and definitely as you maybe have a commercial on TV, you wouldn't want to have someone, okay, now for more information, navigate to 207-7429-48. That just isn't groovy. So instead, we have names like www.grc.edu or www.att.com, and those names are easier for us to remember. And so DNS services allow us this kind of a central resolution process, and it's up to you what DNS server you're using. You see, part of configuration of your workstation and your server is that you can choose which authority you're going to recognize. And there are public DNS servers. So you could say, I don't really trust, you know, my local company. I'm going to use a public DNS server. And that'd be fine. A lot of times viruses are going to attack at the DNS resolution spot, because not only the DNS server helps your computer to resolve IP addresses, there's also a file called hosts, and on Linux is under etc hosts, on Windows is under C Windows System 32 drivers etc hosts. And the same file, in that file you can hard code a name and then IP address. So that file will overwrite whatever the server is telling you. So I have seen viruses which basically put their own IP address of whatever service they put and then Google as the name. So as the end user types in www.google.com, a page comes up that looks like Google, but whatever search you're doing, you know, they're managing the virus company, whatever that company is, you know, their stock market identification. So they will send you to whatever websites they want, and that might be primarily websites with services that they advertise. Okay, so DNS servers and host file, they go together. We're going to look at DNS servers later on, and what you will notice is that if you modify the host file, it works for ping, it works for your browser, it works for other services, but if you say whois, which is a command to verify DNS activity and DNS data, that application skips the host file. So we'll see that difference. And then I'll ask the question, why would you ever want to use the host file? And there are some good reasons why the host file is there in place. Okay, so DNS. Any other protocols you can think of? What's that? PHP you said? Oh, DHCP, yes. Dynamic Host Configuration Protocol. So DHCP is very useful for network administrators where maybe you have a Linux box, and on this Linux box you configure a DHCP server so that you don't have to walk to every workstation and give it a static IP address. And these dynamic IP addresses work within a broadcast domain, so within a network. And as you separate networks, you need to provide access to a DHCP server. Which reminds me about our next week's class. If you have your virtual machine configured in bridge, so in the bridge network system, which means that you actually have an IP address for the real network, for this classroom at least. Do not configure a DHCP server, because if you start the DHCP server, it will broadcast that I am now the authority for giving out IP addresses, and it makes browsing the internet difficult for the rest of the people on the network, because suddenly those IP addresses get re-released and expired, and it just makes a mess. It's one of the reasons why we have our own set of IP addresses for I think this classroom specifically. Okay. So DHCP, yeah, great example. Any other ones? Okay, POP3. So now we're talking about mail services. There's POP3, there's IMAP, right? And those protocols, again, traveling at the application level, they're still based on IP, TCP/IP, but they're traveling on top of it, and they allow you to download mail or create mail and send it to a server. Yeah. Any other ones? How about what is used by the mail server as it sends mail to another mail server? What's that protocol? Yeah, so simple mail transfer protocol. Yeah. So very much like what we see with HTTP, there will be a header, there will be a body of a message. These application protocols are based on that kind of structure. Unfortunately, SMTP is also not encrypted. So next time you send out an email with a password, you may want to consider the fact that people either have already copied it or it got out. Excellent. Well, there are many other protocols there as well. We'll touch on some of them. So now let's take a look at our Linux system, because the bottom line is that networks are made out of a hybrid of systems. Windows, some of them will be Mac, some of them will be Linux, and the same rules apply to all of these as far as what's an IP address, what elements you have to configure. So I'm not going to go over too much in terms of theory of the networks. What we want to see in this class is how to configure those things on the Linux system. So we'll look at specific commands, we'll look at some of the practical elements. Okay, so let me log into the desktop. First of all, let's check what our current IP address is. And this is done by issuing ifconfig. Now, the first aha moment for me is that in previous versions of Linux, you could not run this command, ifconfig, as a regular user. You had to be super user to do that. But because everybody wants to know their IP address, okay, now we can do that. And on a Unix system, most of network subsystems are privileged area. So that's why you had to be super user to use ifconfig. ifconfig is also used to configure interfaces, so to change an IP address, right? Which is why only super user had access to it. Well, take a look at another utility like ping, and let me see where our ping is hiding here. Notice that the ping command also, because it has to use the network subsystem, it has letter S in the 4th position here under our security settings. What does that mean? And does anybody remember from our file system discussions? What does this S here stand for? Right, this is, it runs as root, right. So it's a sticky bit that's set on the portion of the owner of the file. This is the owner of the file, root, and read, write, execute would have been the normal setting. S means that when whoever is running ping actually runs it with root's permissions. Okay, so that's how we check our IP address. Who knows how this command works on Windows? Yeah, I always get confused which one to use. But yes, on Windows, you can issue ipconfig, and you will get related information, so your IP address and so forth. So ipconfig on Windows, ifconfig on Linux. It's for interface configuration. That's where the F is from. Okay. So here is an IP address. An IP address is made out of 4 numbers. IP address version 4, right? Actually, IP address version 4 is made out of 4 numbers. It's probably unrelated, but I just realized that. These numbers, we call them octets. Does anybody know why we call them octets? There are only between 1 and 3 numbers. How come do we call them octets? Say it, 8 sets? Right, so there's an 8 out there somewhere, but so 8 sets, I mean, we see only 4 sets, right? So why call them, so this is an octet, that 172, this is an octet, this is an octet, and this is an octet. Sometimes you will hear people talking about the 4th octet or the 1st octet.
It's a 32-bit address, so it uses 8 for up to 4 times.
Yes, excellent. So I don't know whether this address is in binary. There's a website you can plug it in and it'll calculate it. But I actually know what this number is in binary. So we'll, for convenience sake, we're going to use this one. So this address right here in binary would be written as 1, 2, 3, 4, 5, 6, 7, 8 once, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So that's why they're called octets, because in binary, to express value of 255 in decimal system, you have to put 8 ones. So the first one stands for either 0 or 2. The second one stands for 2 or 0. The third one for 4 or 0, 8 or 0, 16 or 0, and it goes forth. So when you add all the numbers, it's 255. Okay. As you look at this number then, and there are 32 bits in this number, you probably realize that there is just a limited number of numbers, of options here, right? So one of the problems with IP version 4 is that the internet grew to such an extent that we are running out of these IP addresses, the routable ones. Let's say that you have a home network, and at home you have 5 laptops. Usually only your modem gets the real IP address, and all the other addresses have local network addresses, which are NATed, network address translation, which allow us to save some of those IP addresses that can be reused. But today, you have a phone with data on it, you have an IP address. You have a refrigerator that gives you current weather conditions, you have an IP address on that, right? So all these systems require IP addresses. I think some of the new vans now actually are hotspots. So they have a little access point in them, and they have IPs on them. So that's neat. But that is the downside. So the newer protocol, IP version 6, adds a few of these zeros and ones. How many? 128, right. So when that is the standard, I'm going to stop writing the ones and zeros for presentation. So 32 I can actually handle. But you can see this is 32, 128 bits in just a single address. And that address is expressed in this form right here. Right? So not only do you have numbers, but you also have letters. Because basically once you get from 0 to 9, you can start with letter A, B, C, D, and so forth. And you have, of course, then the ability to have more hosts on the internet, and sooner or later we're going to make the transition to IPv6. Sooner or later. Okay, so once we realize that, well, we're going to use IP version 4 because that's still the main workhorse. In order to configure properly a workstation on an IP network, we're going to need a few key values, okay? And here they are. First, we're going to need an IP address. Okay, and so an IP address would be expressed in my situation as 127.22.204.52. Okay, so what else do you need in order to be able to communicate on an IP network? IP address is the first thing. What else do you need? Okay, subnet mask. What in the world is that? What's a subnet mask?
It's a way to divide up large networks. There's subnet,
Okay.
network.
Okay, great. So subnet mask helps us to configure an IP address and explain which part of this IP address is the network part and which part is the host part. So that when we start broadcasting, see, we only broadcast that to our network, to our broadcast domain. So here is an example of a subnet mask. This subnet mask simply means that the first 3 octets will stand for the network and the last octet will be the host part. And in decimal system, we would write it down as this, which is the most common subnet mask. It's for Class C IP addresses. And I think the textbook mentions the multiple A, B, C, D, E classes of IP addresses. And they differ in the way that some allow more hosts. So Class A would have more hosts per network. Some are local addresses, like 192.168, and so often we see those addresses at home, which are netted. Some addresses, like local loop 127.0.0.1, is also a special address that is just a test address on your loop back. And there are some experimental addresses, or basically for research, and they are usually, I think, the E-class addresses. So, subnet mask. What else do we need in order to communicate on the network? Okay, so MAC address specifically, so 2 different addresses, IP address and MAC address. MAC address is going to be given to us, unless you're running Linux, where you can actually modify it, which is really cool. It's actually hard-coded on the card. And MAC addresses are given to network interface card manufacturers. So NIC is a network interface card. So 3Com has a certain subset of MAC addresses. I think the first few characters explains who made the card, and then the rest of it is the actual physical address. MAC addresses are used on local area networks to talk to the switch. So when the switch gets your packet, it looks at its port and it goes, okay, whenever someone else calls this MAC address, I'll send the packets through this port. In that way, it's different than a hub, which basically sends to all the ports connected, because it doesn't like to be intelligent in any way, and track who is where, which saturates the network quickly and makes it very, very insecure. By the way, most of you have hubs at home, so that's the bad news. So with a switch, you have a MAC address coming from the card to the switch, and then the switch has a protocol called ARP, Address Resolution Protocol. Okay, great. So Address Resolution Protocol, ARP, that basically will take MAC addresses and IP addresses and be able to exchange them. So if from your computer you say, I would like to connect to my colleague's computer this IP address, the switch takes it, it then has to look up in the ARP table what the IP address is, look at the MAC address, and then spit it out through the correct port. So those are MAC addresses, all right? Imagine maybe going on the flight, and you have a ticket. IP address would be your long-distance address where you're going. You may be going through multiple cities, multiple hops, but the MAC address is the gateway, the gate. Okay, so you have your gate number, and sometimes the gate number is switched very quickly on you. You get to the airport and it's actually something different. Well, the switch, as it passes packets from one switch to the other, it'll overwrite MAC addresses. It'll put its own MAC address in the place of the packet and move it forward. So MAC address is sort of a short-term address, and IP is put on a packet, and then the routers are going to track that address. Okay, so MAC address is part of the card, and it's used sort of behind the scenes. But as we are configuring this, interface, we were going to need additional numbers. Before I go on, MAC address oftentimes can be looked up by your operating system. So on Linux, I'll show you a place where you can say probe, and it will find the MAC address and plug it in for you, right? So it's not something that you have to necessarily memorize. It's something that can be looked up. Okay, so IP address and subnet mask. Now that's actually enough to talk to the local network. But how about to actually be connected also to the internet? What other numbers will we need?
DNS.
All right, so DNS, there is, right, if you like the numbers, so DNS, you can have multiple DNS servers. You can have the primary, secondary, tertiary, and others if you really want. So let's see how we look up DNS numbers on a Linux host. Well, we're going to say cat etc resolve.conf. So resolve.conf is a file, configuration file, which will contain the name server, which are DNS servers. And so you can modify them here. You can put in your own. If you have DHCP enabled, part of the automatic configuration is giving you the DNS server names. Also notice the search. Search means when I type in www, okay, don't take me to Google or Yahoo, take me to www.grcc.edu. So basically, when you just type in host name without the domain name, it's not going to say host not found. It's going to match the local domain. And so that's what that's for. Okay, so we have DNS, and my DNS server is going to be, let's see, 172.22.198.101. All right. Great. In order to get out on the internet, we are going to need one more number. Gateway. Excellent. Gateway. And what is gateway used for?
It's the IP address of your router.
Excellent. So gateway is the IP address of the interface on the router that you are going to send all your packets through that do not belong in the local network. And so the gateway. At home, that local gateway for you is going to be your cable or DSL modem. And most of the time, if your address is like this, and this is the host part, then the gateway would be 172.22.198.1. Okay, so at home, whatever number you have, a lot of times it's .1. Now I've seen with AT&T, I think they use the two-wire systems, and they actually use the gateway of .254. All right, so let's look up our gateway. To see the gateway on our system, you have to issue the route command, and the route command shows you your local routing table. And as you can see, my gateway is 127.22.204.1. So I was off. Let's see what I think I put in 198. Was that my?
Yeah.
Oh well. My thinking was right. My typing was incorrect. Right. So on this network, it will be the first host. Okay. And so this is default route. If you are connected to multiple routers, which is very uncommon, really. Then you can configure your routes in a different way. Okay, so here is the routing table. All right, so these numbers right here would be the numbers that you need before you can configure properly a server, right? So you're going to usually be given an IP address. So on server networks, we don't use DHCP for the simple reason that if you are running a web server and its IP address changes, it spells trouble, because your DNS server suddenly sends everybody in the wrong place, and that server might be not a web server. So static IP addresses is usually what you will do use on a server network. All right, does that make a fair amount of sense so far? As far as these numbers, if anybody would like to ask a question about any of these numbers, feel free to do that. So on a Windows host, again, we would have the same set of numbers. If you issue ipconfig/all, it'll give you the information here about, okay, it tells you here what is your actually MAC address, but it tells you also your IP address. It tells you your DNS servers right here, and it tells you the, let's see, somewhere here it'll have the gateway, default gateway right here. So all those addresses are common to other operating systems as well. Okay, so how do we configure these addresses? How do we plug in all these numbers we just saw? How do we plug them in on a Linux host? Okay, the short story is that they're all in configuration files somewhere, which is great because you don't have like a registry setting. It's all in text files. But you don't have to modify text files by hand. You can use different commands. Here's the easiest one. You can type in setup. And so you have to be logged in as root to do that. That's fine. When you type in setup, you get this really neat configuration utility that allows you to configure all kinds of things in text mode. This means that you can connect via your phone and an SSH client, and you still get this pretty interface. So now I can go to my network configuration, and I can say I'm going to configure my ETH0 or Ethernet 0 interface. So this would be the first position where okay, so in this instance we only have one interface card, and so we have the first interface being ETH0. On a single interface card, on a single hardware element, you can have multiple IP addresses, you can have multiple interfaces. Okay, so my interface right here is configured to use DHCP. If I undo it, I can go ahead and type in the very numbers that we just collected. The static IP address, the network, the network mask, the default gateway. So all of those addresses are configured right from this interface. And so if I was to complete that, let's say it would look something like this. 250.172.204.1. And then I have to also put in the, okay, so I save this, and the next thing I would have to do, I'm going to actually cancel out of here, but if I save that information, I could use then the command of if up ETH0. If up, or interface up, means turn on this network interface, or you can say if down, and this would turn off the interface. So once you change the IP address, you would like to restart the interface for the new address to be active. Now, caution, right? If you are remotely connected to your box on a single interface, and you are reconfiguring this interface, it's like cutting the branch that you're sitting on, right? And basically, you're changing the address that you are connected to. You change the address, restart the interface, and you lose the connection. And it's not a problem because you can reconnect unless the firewall isn't yet configured to open the new address, or something didn't go right, you made a mistake in one of the addresses. So there are multiple ways to get around that. You can temporarily configure multiple IP addresses and connect via another IP address and then work on the other interface. Or, last resort, you can write a script that basically is going to automatically reconfigure the interface and restart the computer 5 minutes from now. Right, so if you lost the connectivity, you just have to wait 5 minutes and then things will go back to normal. Okay, so setup is easy, right? I mean, just type in setup and you have all this at your fingertips. The next way of configuring networking is with ifconfig all by itself. And so if we consider ifconfig, it allows me to set an interface, set an IP address on it, and all of that is done on the fly. So ifconfig all by itself allows you to do that. All right, let's move along to the next way of doing that. You can run a utility called system config network. Now, if you do not have this utility on your Linux system, just run yum install system config network, and it'll install it. So when you run this utility, and of course, you have to be root for any of those network address changes. So you go ahead and run the utility, and it's going to start up a pretty GUI, which is very useful, okay? It's very useful. You don't want to make very many mistakes when configuring the network. So you go ahead and click Edit, and now you see you get to type in all the same numbers as we collected initially. Okay. Oh, and this is the button I mentioned before, the probe button. If you don't know what your MAC address is, you can just probe it and it'll use it. Virtual machines, okay? You copy virtual machines, you end up copying all the data, including the MAC address, in a config. And so virtual machines are smart enough that when you start it up on a different system, it's going to try to change the MAC address. And so you sometimes have to come in and reprobe, and it'll tell you what the MAC address is. All right, and so that's this part. Let's look at yet another way to configure network addresses, and this is done. For this, I'm going to actually log in as root. This is done via something called Network Manager. So I'm going to start the service init.d Network Manager start, and Network Manager is a very useful tool, which isn't doing what I expected it to do. There is a there's an icon here that I'm going to recall in a minute, which allows you to manipulate the networks. Let's see, GNOME network properties. No, GNOME, it's icon. Okay, Network Manager, GNOME. All right. Google to the rescue. Network Manager icon. It's a program that I need to find the name for. Oh, okay, NM applet. Thank you. That's what I was thinking. NM applet, and I think I have to run it as the regular user. I think most of you actually have this in place. If you start X from run level 5, this gets loaded automatically. Because I started in run level 3, then started X separately, I'm missing some of these elements. So NM applet could not acquire the Network Manager user settings service. Okay, let's see. Well, I'm sure I could fix that in time. Let's just do this. All right, there it is. Whoa, no, I broke it myself. So now the run level 5 works. Perfect. Let's go ahead and log in. So I fixed it twice. So you have to look at the benefit here. Okay. So the applet is right here, and it uses the Network Manager daemon. And so if I click on it, I can say, okay, select an existing interface, or I can right-click and say, okay, oftentimes on a laptop, this is where you can enable wireless. This is where you get to select the wireless network. And so you can go to Edit Connections, And so this gives you a really nice interface for doing so. Press edit, and so you have another interface for including the same data that, let's see, the same data that we included before: address, network, and then gateway. Okay, so we looked at a few ways of doing that. Now, let's look at how this is done when you do this by hand in the config files. So, to do this in the config files, let's see, we don't need this anymore. You have to be root, and let's start at the beginning. First of all, in order to have access to your network card, you need to have the network card driver. And drivers in Linux are called kernel modules. So you have to have a kernel module that matches your card. And if you're installing Fedora, it's going to match that for you automatically from the CD-ROM. This usually works without much trouble. lsmod is the command that shows you lsmod is the command that shows you all the modules that your kernel is currently running with. Every device that you're running on the system has to be covered by one of the modules, because we discussed that in the past, how the kernel is the main program, is what actually we call Linux, and the kernel talks to the hardware, right? So it has to have software which can recognize the hardware, know what the hardware can do. So that's why a network card needs to have the module. In order to load a module into the kernel, we would use modprobe command. Modprobe allows us to either reload the modules. A modprobe allows us to say modprobe and then the name of the module, in which case the file itself has to be inside of the kernel installation files. For every version of the kernel, there is a directory where all the modules are stored. There is another lsmod. rmmod is another command that allows you to remove a module if it's not used. Okay, so the device has to be disabled, and then you can remove the module. You can see I have some sound card modules here and everything else. Okay, so now that we have the module for the card enabled, we can start looking at the config files. So let's look at the config files we already looked at. Resolve.conf, this is where the DNS servers are going to be configured at. Next, vi etc sysconfig sysconfig network. This is a config file where you can save the host name of your system. So when you type in host, not host, host name, it tells you whatever it is you gave it during installation time. You can change this host name. You can change this host name by issuing the hostname command, but then it's not yet written into the file, which means that when you reboot, this hostname will change. So if you want to set a new hostname for good, then you have to edit that file. The file is under, again, etc sysconfig network. Okay, now let's look at the actual interface files. Let's go under sysconfig network scripts, and here the file that manages Ethernet 0 is called ifcfg Ethernet 0. All right. If I preview this file right now, it only has the hardware address because we are using the network manager utility. So let me go ahead and turn it off. Network manager, stop. Okay, and now we'll go through this utility to go ahead and configure the device. We don't want to use DHCP. We're going to use, let's get my cheat sheet here. All right, we're going to use There we go. Static IP 172.222.04.52, 255.255.255.0, 172.22108.101, and 172. No, I have that backwards. 204.1, 172.22.108.101. Now when I save this, save and quit. Now that I saved it, and I take a closer look at the same file, see all this information that I typed in is in this file. So you can make a backup of this file, or later on you can go directly to modify this file. This file defines what the interface name is. I could have started with calling it ETH1. If you have multiple addresses on the same interface, which is possible, you just create a new file and call it ETH0-1, then -2, and so forth. Okay. On boot, there's an on boot expression somewhere here. Right here. If on boot is set to no, then when you restart the computer, the network interface will be down to start with. So you change that to yes, and it'll automatically be up when you start it. But you see right now, if I type in ifconfig, I have ETH0 set. I can say now if down ETH0. All right, ifconfig, there's no interface. So interfaces are the software configurations that allow us to have an IP address. You can have multiple interfaces on a single network card. Okay, so now I can say if up ETH0, and this brings back up my internet. I can say ifconfig, and here's the information. Now let's see what happens if I try to maybe use a utility like wget. Let's see. Whoops. And so we're connected now. Okay. One protocol we didn't mention so far is ICMP. Anybody knows what ICMP stands for? Internet Control Message Protocol. And it's used in addition to IP because ICMP helps us to track our packets across different routers. So when a packet goes from your computer and it goes to another router, sometimes it'll get stuck in a loop because routers pass information about what's the best route, and as the update takes place, your packet may be lost in a loop. And then it has TTL, or time to live, which is the number of hops of different routers. Well, once it goes to 0, the router looks at the packet and says, oh dear, I'm the last guy that you ever see, and it just drops the packet. Okay, it's by design that way, so you don't have all this traffic monitoring the internet. So ICMP allows you then, once the packet is dropped, ICMP allows you to have a message back to say, sorry, your packet didn't get there. We dropped it. Ping is a good example of ICMP. You see, as this unfolds, you can see that ICMP is being used here. It's a sequence, just the number of pings, and then time to live. We allow 56 hops, and then the turnaround time that we're going to use between us and that specific IP address. ICMP is also used with traceroute and different utilities that give you information about how your traffic is doing, not necessarily actually carrying the traffic anywhere. All right. Yes?
Do you know why back in the day people used to do ICMP floods, like as sort of like DDoS type attacks?
Yeah. So flood.
Why those don't work anymore?
Yeah, good question. So first of all, floods don't have to be necessarily bad. In fact, routers will use flooding as a legal and appropriate mechanism to transfer information to everybody they know about their existence, for example, when they come online. So flooding not necessarily is always bad, but a ping, when you can do a malicious ping, which basically is going to send so many packets to some host that in fact it's going to block the operation of it. So those floods are possible because protocols, when they are designed, often they're not tested to such a degree as to figure out every bad way they're going to be used in. So here is what people do to protect from ICMP floods. If I go to ping www.google.com from my Windows box, nothing happens. The same host, when I do it from Radar, it responds just fine, right? I say ping Google and it says, oh, no problem, look at that. So at the firewall, you can block this traffic, and you can make sure that that this traffic is blocked, and basically only network administrators, if they really need to, they can track this kind of information. Yeah, so NAT is another way to do that, because when you NAT systems, it's sort of a natural firewall where your IP is behind another gateway, and unless you configure again the firewall in such a way that you're in DMZ, no ICMP will get to your system itself. Okay, so at this point we saw some of the config files. We configured our own system. Oh, and what I'm going to do now is I'm going to say IF down ETH0, and I'm going to delete the information from the file. What it is we are on a dynamic network, so if this IP, if the DHCP server says, okay, the lease on this IP is over, it'll give my IP address to someone else. If I hard-coded it already, I will be in trouble and the other person, because none of us will actually be able to talk. So I'm going to set this back, and I will re-enable back the network manager. Oops, start. Okay, perfect. And so let's see. So we talked about how to configure the Linux hosts, and that's great. We talked about mod probe. We talked about ping a little bit. Network manager. The textbook mentions PPP, okay, point-to-point protocol. If you are investigating your cable modem or your DSL, you will see that you have PPP configured between that modem and your ISP. So PPP is used when you have circuit switch lines, when you are connected to another provider or a branch office, and you can use those protocols to connect two LANs, basically. So that's possible with PPP. All right, let's look at DNS momentarily. So let's say that I am configuring. Okay, let's first check google.com, what the address is. Google address, IP address is this right here. If I say, who is this particular address, okay, the database brings back information about the location of the server, or at least where the IP address is registered, right? And I could now open the browser, navigate to this IP address itself. Let's see if my browser is open. I can open a browser, and I can navigate to this IP, and I actually see Google. So I'm now skipping DNS completely, because now I know the number. Instead, I could go ahead and go to Etsy hosts, and I could say, okay, whenever someone says Google, go to, let's go to 207.7429.48, whenever someone says www.google.com. Okay, so what I'm doing now is that if I rerun the same ping command, now it's a different system that's responding, right? Different IP address. Well, if I say who is 207.7429.48, Okay, this actually properly goes to the DNS server and resolves it, and it says, yeah, that Grand Rapids Community College owns that address. At the same time, if I go back to a web browser and I type in, okay, I'd like to see www.google.com, and nothing shows up. See, well, the GRC icon is here. I actually don't know why nothing shows up. Must be some extra protection that we put in place. Let's see if I can fix that. How about web.grc.edu? This server's still up. 231. Okay, let's try this. So Etsy host 231. And so what happens if we refresh now? Oh, none of these want to do anything for me. Okay, let's do something different. Ping www.yahoo.com. Now we're getting desperate, or I'm getting desperate. I'm going to get this address, and we're going to open host file, replace the GRC address, and now I'm going to type in google.com, enter, and look at that. Finally, what everybody expected, that sooner or later Google is going to sell their services to someone else, right? So you go to google.com and Yahoo comes up. And yeah, it's because it's cached. The browser has cached that. If I restart the browser, if I do that and I go to www.google.com, oh, it's still there. Okay, let's go to Tools, Clear Recent History, Clear Now, Edit, for the Preferences, Exceptions, Advanced. Oh goodness, somewhere here there's going to be Clear Everything, Clear, Remove Digital Cookies. Yes. Okay, let's see if that did it. www.google.com. There we go. Right, and so now the Yahoo thing comes. Okay, so that's the DNS server, and again, Etsy hosts would be where we can get around some of those DNS resolutions. Okay, so today we're talking about how the client, the workstation, or the service is configured. Next week we'll talk about how those services actually are configured. Okay. DNS servers. Let's see. All right, so this takes us to cat Etsy services. This is a great file which basically shows us everything that is possible in terms of known services. Right? So if you are ever wondering what services should be on what port, you can just query this little text database. And if you say netstat dash listing ports and show the program that runs along with it, notice that these are no longer numbers. These are replaced by the names of the services. If you want to see the numbers, you add the N, and then you have the same but with the actual numbers. A lot of times people look at the ports and don't really remember what the service is behind, so the other thing is useful. Okay, various services. At this point what I'm going to do is I'm going to again show you my IP address. So this is my IP address, and let me write it down on the board. 172.22.204.52, and I will create a user on my system, user add student, and I'll set a password on it called student. Okay, next I'll start SSH. All right, and so let's see who can log into my system and in the home directory for student create a file with your name on, with the name of the file will be your name. And I'll go ahead and do something really smart like watch ls slash home slash student. And so now when somebody shows creates the file, student. In order to log in via SSH, you will have to issue command SSH, then student at, and then the IP address. Is this command not working? No, I think it'll work. Okay, so the reason why you have to say student at is because you likely are logged in as another user. If you are already logged in as student user, then you can just say SSH IP address and it'll connect you. All right, Patrick is first. Excellent. Anybody else? By the way, please don't change the student password. There are ways to undo it, but it'll Tim, okay, very good. Yeah, just make up a file. So then all you can say is touch, and then your name, and so maybe John. Actually, that's probably not a good idea. Sorry, John. Okay, excellent. So we have David and Justin. That's great. So SSH is really nice. If you did not want to touch John, right, what you could do is instead you could have done this. You could have said SCP, so you could have created the file locally on your system, and then say SCP John being our file name, and copy that to student at my IP address, and then colon dot. And this would also generate your name here. So basically you would say something like, and I'll do it here for my account. I'll say, okay, go ahead and create my file, then do SCP my file to student at 172.22.204.52, and then the colon means now I'll provide the name of the file. I could have provided a different name of the file. I'll say yes, and now I'll provide the password, and you see it tells me that it copied the file, and my file is right here now. All right, perfect. So SSH works. Let's try a different protocol, different server system. This next one will allow us not only to have command line access, but it'll allow us to have graphical user access to the remote system. It's called VNC. Okay, VNC. Is someone okay? So VNC. VNC is a great protocol. VNC is a great protocol because it works on Windows and it works on Linux just fine. So from Linux, you can VNC to a Windows box, see the desktop, and you can VNC back again. Of course, there's also remote desktop, which works fine on Linux, but it's typically on Linux you'll have the client, our desktop, and you're viewing a Windows host. Okay, so let's see how VNC might work. First of all, I will give you access to my desktop. Let's see. You will know that you are on my desktop because it will say student, and so let's do that. Let's do it as student. This is going to be safer. We'll do that as student, and everything else should look the same. So you should have the actual desktop to use. The first step to using VNC is to download the software. On your computers, you may not have VNC installed, in which case, as root, you want to run something like yum install VNC. And then the other command would be let's let me just check here. Okay, so grep VNC. I think the name of the server is right here. So then you would say yum space install space tiger VNC dash tiger VNC dash server. Okay, so you have to have the server installed and you have to have the client installed. The client is called VNC Viewer, but when you are running okay, so I think it's Tiger VNC that you install, and then you install Tiger VNC server. Anyway, once you have those two pieces of software, you would then issue VNC server as the command. All right, let's do this. Let's say VNC server, and now the first time you run VNC server, it's going to ask you, what would you like to create? What password would you like to have? With SSH, the password was in etc shadow. It was the actual Linux account password. With VNC, we are creating a new password, and this new password is going to be only for the VNC desktop. So now I'll go ahead and make this the word welcome, lowercase welcome. All right, so someone has already beat me to the punch here. Let's see, PSEF, grep, VNC. Okay, so as you start VNC servers, and you can have many of them, you will be given the desktop number. So now, in order to attach to this VNC session, all you have to do is type in VNC Viewer, and then provide the IP address. So or what is it? 172.22.204.52, and then :2. Now you'll provide welcome as the password, and look at this. I have another session to my computer, but now I am logged in as student, and I could be doing that from a Windows box and seeing this desktop. So go ahead and log in. We will know that you're successful when this desktop disappears, because right now we are starting these sessions in a non-shared mode, which means that only one person can view this VNC server at a time. The cool thing though is that when I start a program here, it's not going to exit. It's not going to exit even when I shut down this window. So when you have an all-nighter upgrade going on, you can do this inside of the VNC server, and then even if your laptop dies, your upgrade will not suffer. All right. So if you are all right, if you're struggling with that, let's see how we can help. Were you able to connect?
No, I don't think it will let me from the wireless.
Oh yeah. From wireless, it's going to be more difficult. Now here's the cool thing about SSH. You could tunnel VNC through it, but it might be a little bit more than. Okay, go ahead and put the colon right next to the IP address. Okay, like that, yeah. And what does it say? Okay, don't be root. Be the regular user logged in here. So go to File, Open Tab, and then go ahead and type in VNC Viewer. So on most systems, there's a permissions hierarchy inside of X Windows. So if you're trying to run VNC as root, it's not going to work. Okay, let's see here. Go ahead and ping. So you didn't try it here yet. Okay, go ahead. Yeah, VNC Viewer, the address. Just do a space 172.22.204.52. Yeah, and then :2. Enter. All right, something's cooking.
Still working.
Okay, just so nobody has been able to log in? Well, in that case, let me check the firewall. Okay, so the firewall, all right, very nice. We have coming from the dead users. Okay, so firewall is under it's IP tables, and so I can do L to see. Oh, and I probably am blocking it. So one of the reasons why you couldn't log in is because I was going to show you this presentation on firewall. So firewall here, you can check with IP tables-L, or you can say IP, and you can see it. You would say IP tables-F to clear the firewall. Now go ahead and try to connect, and hopefully this is going to. Someone connected. Okay. IP tables lowercase. You're a super user.
No.
Okay, be super user to do that. Okay, so here's the thing. So the first person who connected, I wish I could give you an award, but I don't really have anything. So, so here is where you connected. But now, instead of saying VNC viewer, because it's not really fun when I start it up again and someone else closes it, now type in -shared. And the idea is that once we connect, we all will be able to move the cursor, and you can then go ahead and add your name. You can add your name on the screen. So add -shared, and hopefully you can connect without knocking me out.
I'm not set up nowhere, no how.
Oh.
We started getting
The installation.
Yeah.
That's okay. Don't worry about it. This part is sort of just a fun element. So you're doing. You have to be logged in as the same user who owns the desktop. So you have to be. So just go to File, New, or Open Tab, and then type in the VNC command right in here. Say it again. Go ahead and show me the command. Oh yeah, what you want to do is you want to say cancel and do up arrow, then VNC -shared. No. Did I misspell it?
Yeah,
Like this. Yeah. So that's what you want to type in: VNC viewer -shared. And once you type that in, you should be prompted. Okay, so multiple people are using it now. So go ahead and put your name if you connect it. Okay, go ahead and do up arrow.
Probably under you.
There you go. Do up arrow. Okay, make sure to do shared here, or we're gonna get kicked out. Shared. Yep. Enter. There you go. Just put welcome lowercase and put your name there. Okay, you're on wireless, so you're lost completely. Okay, enable. Okay, let's go up arrow. Okay, don't be rude. Be Anna. Be yourself.
Oh, okay. Maybe that's the problem.
Yes.
Can't see.
Oh, it's too far away? Okay,
Yeah.
go ahead and type in VNC and then press tab twice. Okay, so you don't have the VNC installed. That's okay. Let's go back to this tab. Yep, and type in SU space dash, and then enter. Perfect. And then we'll go ahead and type in the password. Okay, and now type in yum space install. Yeah, install space tiger the VNC.
Tiger VNC?
Yep, try that. Yep. And were you able to connect?
Oh, not yet.
Oh, so you don't need to have students. There's no users.
Oh, okay.
Just have.
That's the-
But go ahead and type in right on the command line VNC viewer. Okay, this is installing. Excellent. It's okay. It's downloading even. Excellent. So don't do that because you're going to kick us out. Because what happens is you would have to go to options and say shared. Somewhere here it'll say shared. So instead of, yeah, oh, it's already shared. Okay, good. So go ahead and 172.22.204.52, and then no, you have to do :2, and then okay. There you go. Lowercase welcome. Okay, did that work for you?
Here's the show getting installed, or maybe I already have it installed, I can't tell.
Okay, Tiger VNC load. What did this say here? Type in VNC and then press tab twice. It's already there. So now go ahead and say File, New Tab. You don't want to be logged in as root for this part. So File, New Terminal, or Open. There you go. Yep, and now type in VNC viewer, and then space, no, you don't want to do that yet though. Say cancel, and say, so up arrow, space, dash shared, then space, and then go ahead and type in 172. Now this is, the recording is in progress, so, okay, go ahead and say okay. I don't think we finished the IP address there. This is fine, :2. So this is the second desktop that we want to look on the host at. There you go, and put welcome. All right, were you able to connect?
I'm getting an authentication error.
Welcome, lowercase?
Yeah.
Okay, let's see. Okay, did someone change the password for? Someone did? Okay, all right. And security failure, yeah, so for you're gonna have to wait a moment. And so lowercase welcome doesn't work for you?
Oh, I was doing...
No, so it's lowercase welcome, yeah. Yeah, okay. Okay, very good. Now, here's the benefit of VNC. What I like about it is that sometimes there might be a problem on the server, and you are with another administrator on the phone, and you're trying to talk about how to fix it. You connect via VNC, and both of you can see what's going on. Okay, that saves time. I've done this with also. Let's say that you have a package that you're supporting. Maybe you're supporting SAP, all right, and you're connected to the server with SAP support. And so now you both can see what they're doing and so forth. With remote desktop, it's not like that, right? With remote desktop, everybody gets their own desktop, so you don't know what the vendor is doing. So there's a reason for that. Okay, you guys are trying to connect too?
Not having any.
Okay.
What am I doing wrong?
Okay, let's type in VNC and press tab twice. Twice. Okay, so go ahead and delete the 3 letters and type in yum install. Delete those 3 letters. Delete them, backspace, and type in yum install tiger VNC, and then press enter. Perfect. Yeah. Oh yeah. Go ahead and hit OK. Let's see. You have to add :2 at the end of the IP address. Yep. Okay. Say yes to that. Make sure. What happened? Let's do up arrow once. Enter. Oh, that's why. You see, you're not connected to the... Oh, you now are. Go ahead and say yes. Why? Enter. Okay, this right here connects you to the internet. And I'm just wondering why... Why is... Settings. That is fine. So for some reason you're not connected to the internet. Oh, that's different.
He's over here.
Yeah, network manager restart. Let's do this. And system ETH is right here. I think we're very close now. This is going to download. Did yours download? Okay, so now we have to type in the correct command. This is almost right. You're really close. You're just a :2 away. Type in :2 and press enter. And the user is, or the password, you're getting there. There you go. Password is welcome. Okay, perfect. Type in VNC viewer, space, dash shared, space. Yep, shared like that, yep. Space 172.22.204.52. And then Control C, or OK for that, and then :2. Okay, :2, enter, and then welcome is the password. How you doing? You're doing perfect, but you're just 1 space away. And you don't want to run this part as root because X Windows, yeah.
Yep.
Press enter. Whoa, let's see what happened here. VNC viewer, oh yeah, see that there needs to be no space here.
Oh, yeah.
Perfect. Type welcome, lowercase. Okay, great. Did you log in?
Yeah, when I typed up.
Okay, you're doing very
badly.
well. No. I've seen worse. Is that helpful? No. So here's what we're doing. We're going to do this. We're going to say VNC viewer like this, and this is very close like that. So we're looking at the second desktop. Press enter. And go ahead and put welcome there. Were you able to connect? Oh, same error. VNC viewer shared. Go ahead and press enter once again. Yeah, I think so. Yeah, I think you're right. 204, yeah. Ah, there you go. Okay, so as fun as this is, you can see that network configuration is very particular when it comes to numbers. These numbers have to be just right. But the bottom line is it's not really that difficult. I mean, once you do it once, as long as you type in things correctly, it's fine. Okay, so the textbook covers VNC on page 561 or so. And again, I love VNC because it allows you to go from Windows to Linux. And there are VNC clients for Windows. I think VNC, free VNC. You can make a game out of it, right? Okay. So with everybody playing, I'll show you how you can, now what you can do is you can say, log in as student and VNC server dash kill second desktop. Right? That's how you fix it. Yeah, I know. All right, so so that's what I have for this week. Let me pause this.